Hi Michelle. I'm going to do the same thing for CMP for Tuesday and Wednesday. So this is just going to be the video that you can play all the way through, pausing whenever you need to. So for Tuesday, this is our daily math. You can go ahead and have that up on the board, and then have students reveal it. Tuesday is a sticker day. Tell them that I'll give them a sticker day on Friday. So that'll balance that out, since they missed one today since I'm gone. So this is the daily math. And then solutions should be 39, 30, 15, and 37. And today, students need out their notebooks. We're going to take some quick notes on the distributive property and combining like terms. And then today is going to just be practicing that. Okay, so the distributive property, there is a poster over on the side of the room called Kiss Your Parentheses Goodbye, and I know we've talked about this a little bit. The distributive property basically means that you can distribute something that's right outside the parentheses into the parentheses. Okay, and we're going to do a lot of swooping is what I call it, with two swoops into the parentheses. So this can be A times B plus A times C. Okay, so if we think about that with numbers, this would be the same as 3 times 2 plus 3 times 4. And it works the same from subtraction as well. If we had 2 times 5 minus 1, that'd be 2 times 5 minus 2 times 1. Okay, so those things work. And you guys have seen this before, maybe not called it distributive property before, but we know that's the case. Okay, and we're going to use this because we're going to be solving equations this week, and this is important for that. Okay, I have these two boxes here because sometimes it's nice to see a visual with this. If we think about this 3 times 2 plus 4, it's kind of like this. If we have two squares here, and we have or two rectangles, and this is a 3 by 2 and a 3 by 4. If we look at the area of these two, this would be 3 times 2, right? And this would be 3 times 4, okay? So if we want to visualize that, so that would be, we need 6 and 12, and then we add 6 and 12 together to get the entire thing. Okay, so what we're going to do is we're going to look at all of this with variables, okay, with letters in our expressions. So what if we had 3 times x plus 4, okay? And that would look, if we set it up on the diagram, 3 times x plus 4, well, the area of this box would be 3x, and the area of this box would still be 12, okay? So that equals 3x, because 3 times x is just 3x, we call it, plus 12, all right? And this is more simplified than this, okay? And you're going to see tomorrow how this will come in handy, but we need to work on this skill of distributing, okay? So we have some practice problems for you to do today. The other thing I want to work on today is called combining like terms. So if we have an expression here, and this is only when we're using variables. If we have 3x plus 4 plus 2x, I want to simplify this expression. So I'm going to combine like terms. Like terms are terms that have the same variable or variable ending, okay? So here I have 3x's, and later I have 2x's, so I'm just going to put those together, and I have 5x plus 4. All right? And let's do another one. If we had 6x plus 7 plus 3x plus 2. Here, 6x and 3x are like terms, and as well we have 7 and 2 are like terms because they're just whole numbers. So I can simplify this as 9x plus 9. Alright, let's try another one. Let's try 10x plus a negative 3 minus 4x plus 8. Alright, so I'm going to pick out my like terms. I have 10x's and minus 4x's, so if you're uncomfortable with minus 4, let's make that a plus a negative 4. And then we also have a negative 3 and a positive 8. Those are like terms as well. So if I simplify this, 10x plus a negative 4x is going to be 6x's, and then a negative 3 and a positive 8 is a positive 5. So let's do this one, and let's have you guys try this just on a piece of scratch paper or in your notebook. If we have 11x plus 4 minus 10 plus 2x. Pause the video and see if you can get that one. And you should get 13x minus 6, right? What if we have 4x minus 3 plus 5 plus x? Pause the video and try that one. Well, 4x and this x, how many x's are here? This is just one x. When there's no number in front of it, that's an invisible 1 because there's one x. 1 times x is going to be whatever x is. So we can combine that. That all together is 5 x's. Negative 3 and positive 5 gives us a positive 2. All right? So if we feel good about that, then we can try the worksheets that you have. If you have any extra time, what I'd like to have happen is for students to come up and either give a distributive property problem with a variable or and combining like terms. I want somebody to come to the board and write one up and then have the entire class solve it. And this should be done after the worksheets are done. If you have a lot of time, then you can use the whiteboards to do that. Okay, so that should be Tuesday. And then on Wednesday, here's your daily math. There are answers. They were supposed to find what x was. And today we are going to be making math or solving equations guidebooks. So I need everybody to get an 8.5 or a blank sheet of paper, blank sheet of computer paper, and we're going to make little booklets. And hopefully somebody in the class has made these before so that it is maybe easier and you can help each other out. Okay, but what we do here is you take your blank sheet of paper, and first you're going to cut or fold it, not cut it, fold it in half the long way. Okay, kind of hot dog style if you guys have ever heard that. So fold it in half the long way and then open it back up. And now you're going to fold it in half the other way, hamburger style. Okay. All right, so now you have a crease there and there, like seen on the picture there with those red creases. And then from there, you're kind of going to make a paper airplane almost, and make 2 more folds so that you have 8 little boxes. See how mine kind of looks like a paper airplane? I have a T, so I folded it in half and then I folded the sides down like this. Okay. When you have that, then you are going to cut the middle 2 lines there. And if you hold it like a paper airplane here, It's just one cut right up to the fold, okay? And then it should kind of do this. And then if you just pick it up and wrap it around, it makes a little booklet that has different pages. It should have 4 little pages, okay? So then from there, on the front cover, and you can pause the video and help everybody out if you need to. From there on the front page, I want you to write either Solving Equations Guidebook or just your name, and you can decorate it with symbols there if you need to. You can pause the video while people are doing that. On the inside cover, so this was the front page, on the inside cover right here, I want you to write the golden rule of algebra. And the golden rule of algebra is to do unto one side of an equation as you do to the other. So pause the video and make sure everybody has that down. So on that same side, golden rule of algebra here, the goal is to get the variable by itself, to get x by itself, y by itself, z by itself, anything by itself is what we're trying to do. Okay? And then variables are letters that can be replaced with different numbers. So you can write a bunch of different variables there if you want to. You can pause the video and get that done. Then step 1, this should be on the first page here. Step 1 is to eliminate parentheses. And yesterday we worked on distributing. That's what we're going to do here. So for example, if we have 12 equals 3 times x plus 4. You guys know now that this is going to say 12 equals 3 times x is 3x, and 3 times 4 is 12. Okay? So that's the first step. Make sure that everybody gets that and an example down on that page. The next page is to add, and actually I don't want that to say add, I want that to say combine like terms on both sides. So if we have 3x plus 7 plus 2x equals 4x minus 2 minus x, then on both sides we need to combine like terms. So I see we have x's here, and then on the other side, it's very important that on the other side you do it separately. They're not on the same side, so you can't add them all together because this equal sign will always draw a line. I like to, as soon as I have an equation, draw a line down from the equal sign because we have to, this is our scale. This is what we need to keep balanced. So over here we have 5x plus 7, and then that's going to be equal to 4x minus 1x is 3x minus 2. Okay, and we'll continue from there. But adding like terms on both sides if it needs to be done. This might not always need to be done. Step 1 might not always need to be done. Step 3 is to make sure the variable is always on one side. So in step 2, we ended up with 5x plus 7 equaled 3x minus 2. We need to make sure the variable is on one side. Again, I need my line down from my equation or my equal sign. To get an x on either side, we usually get rid of the smaller x. Okay? So I'm going to get rid of this 3x. And how do I get rid of something? An operation that gets rid of something is to subtract. So I'm going to subtract 3x's from both sides. So I subtract 3x. Okay? And then I like to draw a line like this. 5x minus 3x is 2x. 3x minus 3x is 0. So now I have 2x plus 7 equals 0 minus 2. So that would be 2x plus 7 equals a negative 2. Okay? Alright, that's step 3. Step 4 is to eliminate the constant term. Okay, so if we have 12 equals 3x plus 4. 4 is my constant term. Okay, this is my constant. Alright, so to get rid of a positive 4, I'm going to subtract 4 from both sides. And 12 minus 4 is going to give me 8 equals 3x. Okay, this also could be, what if we had 12 equals 3x minus 4. Okay? Now if I have 12 equals 3x minus 4, to get rid of that negative 4, that minus 4, I'm going to do the opposite, so I'm going to add, because a negative 4 plus 4 gets me 0. So I'm going to add 4 to both sides, and make sure I have my line down from my equal sign. Negative 4 plus 4 is 0, and I have 3x here. 12 plus 4 is going to be 16. Okay? That's eliminating my constant term. That's step 4. And the last step here is the coefficient, and that in the last two cases would have been the 3. Okay? So if I would have added my 4 to both sides here, and I made this one nice, I have 15 equals 3x. So this is my last step. I have to get rid of this 3. If you guys remember from distributing, this is a 3 times x. So to get rid of that multiplication, I'm going to do the opposite of multiplication, which is dividing. So I'm going to divide by 3 on both sides. And I really want you guys to use a division bar, a fraction bar for dividing here. Okay, don't write this little sign. I want you to use the division bar. All right, and 3 divided by 3 equals 1. So I have 1x, and then 15 divided by 3 equals 5. So I have 1x equals 5. And then that, since I only have 1x, or just x, I could also just write this as 5 equals x. I have made, or met my goal by getting the variable by itself. Okay? So now that you have your guidebooks, we are going to practice this. So everybody needs a whiteboard marker, whiteboard, and sock. And we're going to practice this on whiteboard. So what I need is everybody do that, and then I want one person to come up to the board and over on the side write out these problems. And if you want actually a couple people to come to the board, that'd be fine too. So we're going to go through a bunch of different problems and solve them, and you should be able, if there are any that you don't understand, please write them down and we'll address them on Friday if there were any that really caused people problems. So I'm just going to flip through these, and you can pause the video and play it as you need one more. Okay?